Good day, my friends. Welcome to the episode number 6 on introductory lectures on Geogebra. Today, we'll show you some functions um, which can be written in equation form. For example, equation of a circle, equation of an ellipse, equation of a parabola. I will just mention those three, and then I will start an important topics on sequence. So first thing is what I intend to do is that can GeoGebra really identify these familiar equations, for example, this equation, which is the equation of a circle whose center is at A and B and radius is R. I will specify A and B and R either in form of sliders, or in directly I can put the numerical values, or say the equation of of an ellipse like this, y by b whole square is equal to 1. Familiar equation. And maybe the way we write equation of a parabola is 4ax, isn't it? So xy relationships are written in the form of an equation, and whether GeoGebra can help me out to sketch those items like circle here, parabola, and an ellipse. Let us see that. So to do that, we have to, of course, start our GeoGebra, and here we start it, and as usual I select this algebra view, and here straight away I write this equation. For example, you write x minus 1 whole square what is that caret, whole square plus y minus 2 whole squared is equal to say 3 square. So it faithfully draws the circle whose center is at point 1, 2. Here is the center, and its radius is 3. Okay, this is how it will be drawing, and of course if you put enter, it will give a name to the circle as equation 1. Okay, and then natural thing will be if you suppress the circle now and write a general equation of a circle, which we have been doing like this: x minus a whole squared plus of y minus b whole squared is equal to say r square. So this is the general equation of a circle whose center coordinates are a and b and radius r. And we know if this a, b and r have not yet been defined, but GeoGebra will give you an offer in the sense that it will create, we know, 3 sliders with a, b and r. Hopefully it will do so. Yes, it does. And this is the slider a, that is the x coordinate. You can vary it to whatever value you want. For example, like this, if you vary the x coordinate of the circle, keeping y and the radius fixed, it will move like that. Similarly, you can vary this one and get the locus or the circle at various values of b, that is the y coordinate. Radius generally is a number, positive number, so I will go to this radius settings and make it go to the slider and make it to vary from 0 to 5, 0 to 5 with a say increment of 1, just like that. Clear? So this is the thing. And as you know, I will just mention that if you play this out, it will give you the locus that we know. If you play both A and B, it will also give a locus. So when A and B are being varied, radius I am keeping it at R, that also can be varied. If I do that, what happens? Then radius also goes on changing and things like that. Okay, so I stop it to play, and radius I keep it somewhat low, and this is how A and B is changing. When radius is 0, it converges to a point, as you can easily see. Clear? So I stop playing radius and fix it at some value 2. Clear? Okay, and just to tell you one thing, that okay, this is fine, but you can also, as usual, make a trace of it to create some pattern. Whether something good comes, then you can use in some documents, etc. So I go to the setting of this function here, and ask Geogebra to show trace as well, and it is going to show the trace of these circles if you only vary r, isn't it? You can put it a bit higher, this one. You can change the axis so that it can be shown, and if you play it, it will be showing this object equation 2, which is nothing but the circle, and you can change it like this, 0 to 5. Clear? And you can also stop it, and you can vary A, then you can play only A, and then it will create a pattern like that. Whether that pattern is aesthetically beautiful or not, that you decide, and can do many things here. That I leave it to you to do that. Anyway, so my intention was first to show that equations can be written like this, okay, and you can this is for circle. Let us try to write down the equation of an ellipse. So I cleared my board by going to this 3 lines here, dashboard, and clear all, I say. Don't say. So this is the thing. Now let us see how the ellipse can similarly be written. X by, and I will straight away write the equation of an ellipse in general coordinate form, that is x divided by a whole squared like this, and then plus y by b whole square, y divided by b whole square, and this is equal to say 1. Okay, and if you return, you will be created with a and b, Oh, it does not look like an ellipse, it looks like a circle because major and minor axes are 1, 1. In default, the value of A and B are said to be 1. And you can easily see if you vary it really becomes an ellipse and it changes the major axis. Similarly, if you vary it like this, it changes the minor axis. Got the point? So ellipse can be drawn, and if you see, if you vary both of them together and try to create a pattern, so to say, and can rather switch on its traces. Let us see what kind of pattern it makes. Okay, not bad, beautiful pattern. But only thing, the increment value, if you make rather large, then instead of this everything is colored like this, it appears to be, you can uh, change it in this fashion that okay, the color you can the setting of A and B, you rather make it slider, increment is 1, and this setting you go, and you B slider, its increment also make it 1, and that's all. And then remove the traces. It is like this. Current value of A and B it is taking to draw this ellipse, and you can play them. Oh, fine. This is a nice looking pattern, is it? Okay. Now you can play with this. This I leave it to you. Some pattern you get looks nice and not bad. Anyway, so this is the equation of an ellipse. We can write. I will clear it out. I will go here and say clear all. Don't save. It is not needed to be saved. Acha, does it take the equation of a parabola? For example, y is equal to, I'm not sure, let us try this. Why not, it will do. 4 into a into x squared. Yes, it has taken. It is a parabola, is not? Y equal to 4x squared. 4 into 1 into x squared. If you vary a, it will be a parabola like this. Clear? Clear. Or you can alternatively write this equation as y square to create parabola of this kind. In school days I used to start from this. So far I remember, if my memory goes right, our teacher used to write this equation as y square equal to 4a x. Does it take? Yes, it takes. This kind of parabola we started when we started learning maths. So this is the equation of a parabola. Clear? Y square equal to 4x, and as you can see, I have chosen the value of this a to be this. This is the thing, and if you play it, can it be played? No. Oh, you can vary this one. Why it got stuck up here? Oh, I have not put the return. I will put the return and then vary it. So it becomes a parabola. Because a value can assume negative, both sides it will show it. Similarly, one can try drawing hyperbola and things like that. I will not be repeating those. You can try on your own now, and you can only see that. And you can also, as you know, segment of a function, we know you can create the parabola over a segment, and then can make its trace to work. For example, this trace, if you work, what does it do? So trace, plate, oh, not bad. So this kind of patterns one can create. Clear? And once again, this is not bad, like a butterfly it looks like. And you can make it multicolored depending upon the value of A, etc., which I will not repeat once again. You will feel bored, but you can try on your own. So in essence, what I am trying to tell is this, that this type of equations also GeoGebra handles very efficiently. You can you may write any expression involving y and x. Hopefully GeoGebra will try its best to produce that plot in your graph paper, in the GeoGebra graph paper, to this scale. Is that clear? So so far every lecture I will always refer to some graphs or equations like this. So now what I am going to do is I am going to begin just at the beginning of an important instruction that is called a sequence. Sequence is, let me write straight away what the sequence is. Sequence is verbally, if I tell, it is collection of some numbers, maybe collection of some functions with a definite number of elements in it. For example, you can have a sequence of number 1, 2, 3, 4. This is a sequence, okay, and each one is called an element. Okay, now how to create sequence? One way of creating ordered sequence, a disciplined sequence, is to, for example, take any function fk. Follow me carefully, fk, and then you say that the variable of this function is k, comma, and vary k starting from 1 to say 5 with an increment of 1. If you write like this, what it is going to do is, it is going to create a sequence of 5 elements with values f1, comma, f2, comma, f3, comma, f4, comma, f5. Whatever will be the functional values of k, that will be created, and this is called a list. So the summary of whatever I have told here is that whenever you ask GeoGebra to implement this instruction, fk I will supply, and k is the variable of the function, and I will tell its range, how it changes, starting value, finishing value, and the increment. Then in return it will give me a list, and it will name, if I don't name it, it will name like L1, L2, a list of numbers like that. Without much talking here, let us go to the working board and clear everything there. So I clear now, clear all, Where is that clear out? First one only. Don't save it. It is there. Okay. Bring the axis here. Now I start writing my simplest sequence. See what exactly the way I told you. I will write it like this. Sequence. First bracket. Some function of say k, or that variable could be anything, k, I, a, this variable, you understand? I think you have this variable f k, it could be I also, j, a, b, whatever it is. Okay, but excluding x and y, don't write x and y. X, y are special things about x-axis coordinate, y-axis coordinate. Okay, now let us come back here, and I was doing like this. So go here and write sequence is equal to say 2 to the power, oh what happened, 2 to the power k, and then comma, the name of the variable of this function is k. Oh, where the things have gone? Sequence, sorry, we made some mistake here. 2 to the power k, 2 to the power k, comma, k, comma, 1, comma, finishing value of k, that is, suppose I will choose it 5 with an increment of 1. In default, this increment is taken to be 1, but nonetheless I write in its full form so that the logic is understood by you. So you see, in return it creates a list. You press the enter, it writes that L1 is a sequence of this number 2, 4, 8, 16, 32 in an ordered fashion. This sequence, it looks like a GP series, or no, anyway, you understand. 2 to the power 1, 2 square, 2 cube, yes, 2 to the power 4, like that. So it will simply create a sequence of number. Now this sequence of number, if you are interested in any of the elements, suppose you want to know what is the third element of the sequence L1, you simply type element of what? Of the list, that is L1, comma, whichever element you want. There are 5 elements, suppose you write 3 here, 3, and you see it will return you the value of the third element 8. If you have written L1, comma 5, it would have written 32. You have understood the idea. But one thing you note that when you type this instruction, sequence, creating a sequence with a function k varies like this element, it does not produce anything on the graph paper. Why it should? Because for example, if you try write what I mean to say, if you write a 1, 2, it is going to produce a point, because GeoGebra knows 1, 2 within parentheses is the point. But here simple numbers like this cannot produce any output, because you have understood the point. But nonetheless, this sequence has been created, and you can access to any number you like. Now the question is where this should be used. Sequence is a very important concept, and it will be used extensively by me at least, and you should learn that, I feel, so that much more complicated jobs can be done very easily and efficiently. Acha, for example, if I say, now you see varieties of this particular instruction in a different flavor. For example, you write sequence, okay, follow me carefully, and then I write the coordinates of a point which is k comma 2. Geogebra understand within the parenthesis k comma 2 is a point, okay, and it expects that k will be supplied by the user, and if k is not supplied, it will create a slider, things like that. We have understood that. But here I am trying to do, now here this thing is this 2 to the power k thing here. It is some function of k, the coordinate of a point. See, it is not a function as such. It is not k comma 2 is a point, but nonetheless this point thing is depends on k. As you change the value of k, the coordinate of this point is going to change, and therefore instead of this function k, I can write this, and then I can write k, let it vary from say 1 comma 5 comma 1. You do like that. Now this time if you press return, I expect something will come out here on the screen. Let's see. No, made some mistake here. What mistake did I do? Sequence k comma 2. Oh, I forgot to write down the name of the variable here. See, you make mistake, then you learn many things. That is the worst thing. Yes, now it has done. I forgot to write down this k here. This is the function. Function means it could be the functions we understand, or it could be, it is not really a function, coordinate of a point whose x coordinate depends on the value of k, and that value of k I defined here, starting value, finishing value, and 1, and it creates 5 points. Understood? Now anyway, today I will stop here, and I will request you to go through this lecture carefully, particularly the sequence part. The function plotting part was just an extension of what we did in earlier class, but get used to it, and more talking on this sequence, which, as I am telling you, is very important concept, and you can draw these 5 points in one stroke. For example, one could create these 5 points by writing down the coordinates, point A 1 comma 2 within parentheses, another instruction 2 comma 2, 3 comma 2. Is not in this separately you could write it, but if you want to get the points in one stroke, I take the help of sequence. Okay, many tasks are done in one stroke. Hopefully you have understood it and enjoyed it, and you go ahead, okay, with your learning of GeoGebra. I will go on giving you this kind of inputs. So next lecture we'll continue with this sequence in a much deeper sense. Okay, thank you so much for watching the video. Thank you. Have a good day.